Why do all the planets orbit in the same plane? Many planetary systems in the universe, including our own, have planets orbiting a central star. Our planetary system is called the solar system because it's centered around the sun, named Sol, from the Latin word solus, meaning sun. Anything associated with the sun is termed solar. Hello and welcome to ZE. Please don't forget to subscribe and hit the bell icon. When astronomers began observing the planets, they noticed that Mercury, Venus, Mars, and most other planets in the solar system move in nearly coplanar orbits. But why is this? The current understanding is that during the formation of the solar system, the planets emerged from a disk of dust surrounding the sun. Since the dust formed a flat disk, the planets also formed within this same plane. Let's dive deeper into how this process works. Planet formation. Recent research on exoplanets, those beyond our solar system, shows they vary significantly, with some experiencing diamond rain, while others have iron or ice cores. These planets may rotate in different directions, have varying speeds, and come in different sizes. Some might be habitable with oceans, while others are so close to their star that they experience intense volcanic activity. Despite this diversity, one thing is common. All planets form in circumstellar disks surrounding their stars. To understand this, let's use our solar system as an example. Stars, like our sun, form from the gravitational collapse of giant gas clouds. Initially, these clouds are in a fragile state of balance, and a small disturbance can trigger their collapse. This causes the gas molecules to clump together, shrinking the cloud. External events like the explosion of a nearby supernova may have triggered this collapse. As the cloud collapses, it heats up, creating pressure that balances gravity. When this balance, called hydrostatic equilibrium, is achieved, a star is born. Stars are massive, hot spheres of gas that form from these collapsing gas clouds, and our sun is no different. At this point, a disk of material, called a circumstellar disk, forms around the newly born star. This material doesn't fall straight into the star, but spirals around it due to the star's rotation. The sun's rotation, along with the rotation of the planets and their orbits, comes from this initial spinning motion of the collapsing cloud. As the material continues to rotate, it flattens into a disk due to the conservation of angular momentum. A simple way to visualize this is by thinking of how clothes spin in a washing machine, moving in a circular path. The material around the sun behaved similarly, forming a thin disk billions of years ago. Over time, small objects called planetesimals formed in this disk through collisions. These planetesimals eventually combined to form the planets. Today, the major bodies in the solar system still revolve around the sun in nearly the same plane, known as the ecliptic. However, our solar system isn't just made up of planets. Smaller bodies like asteroids and comets also orbit the sun. Many of these are ancient remnants from the early days of the solar system, and their orbits are more inclined than the ecliptic, showing they didn't follow the same formation process as the planets. Much of this debris is found between Mars and Jupiter in the asteroid belt. The largest asteroid, Vesta, is about 530 kilometers in diameter, while smaller asteroids can be less than 10 meters across. The combined mass of all the asteroids is still less than that of Earth's moon. Some asteroids share orbits with Jupiter, Trojan asteroids, while others, known as near-Earth objects, NEOs, come close to Earth. NASA closely monitors these NEOs because they could potentially pose a threat to our planet. Current space missions, like the DART mission, are exploring ways to deflect potentially dangerous asteroids. Orbital inclinations and the ecliptic. While most planets orbit within the same plane, there are some exceptions. Earth's orbit around the sun defines the ecliptic, and other planets' orbits are measured relative to this plane. For example, Mars has an orbital inclination of 1.8 degrees, while Mercury's is 7.0 degrees. Pluto, on the other hand, has a highly elliptical orbit inclined at 17 degrees, which gives it a very different path from the other planets. Pluto's orbit even crosses Neptune's at certain points, such as between 1979 and 1999, when Pluto was closer to the Sun than Neptune. Because Pluto's orbit is chaotic, its position is difficult to predict over long timescales. In conclusion, the formation of planets and planetary systems is the result of processes that take billions of years. Simple physical laws explain why planets and galaxies tend to take the shape of disks. But the universe is inherently chaotic. Small disturbances can lead to unpredictable outcomes, like planets with highly inclined orbits, such as Pluto, or other irregularities in the cosmos. The solar system's structure, where all planets orbit the Sun in roughly the same plane, is one of its most distinctive and intriguing characteristics. This plane, known as the ecliptic plane, is closely aligned with the Sun's equator. To understand why this happens, we need to explore the processes that govern planetary formation and dynamics in space. 1. The formation of the solar system. The story of why planets orbit in the same plane starts around 4.6 billion years ago with the formation of the solar system. Before the Sun and planets existed, there was a massive cloud of gas and dust known as a molecular cloud. The gravitational collapse of a dense region of this cloud triggered the formation of the solar system. As the cloud collapsed under its gravity, it began to rotate. This rotation caused the material within the cloud to flatten into a disk due to the conservation of angular momentum. This is a fundamental principle of physics that ensures that as an object contracts, it spins faster, much like a figure skater pulling their arms inward to increase their rotation speed. This rotating cloud of gas and dust formed a structure known as the Protoplanetary Disk. The material in this disk was pulled toward the center, where it eventually ignited nuclear fusion to form the Sun. The remaining material in the disk began to coalesce through collisions and gravitational attraction, forming planetesimals, small solid bodies that would eventually become planets. 2. Conservation of angular momentum. One of the key reasons planets orbit in the same plane is due to the conservation of angular momentum during the collapse of the molecular cloud. As particles in the cloud began to spiral inward toward the forming Sun, they naturally moved within a flattened disk structure. This disk shape arises because, as the cloud collapses, it conserves angular momentum, meaning that particles at different locations in the cloud tend to align their movement along a common axis. This flattening results in a disk-like structure where most of the material rotates around the Sun in the same direction. Angular momentum prevents the material from falling directly into the Sun. Instead, it orbits the Sun in this flattened disk. Consequently, the planets that formed from this disk inherited this shared motion, which is why their orbits are generally confined to the same plane. 3. Accretion of planets within the disk. As the protoplanetary disk persisted, particles within it collided and stuck together, gradually forming larger and larger bodies. These planetesimals orbited the Sun within the disk's plane, continuing to collide and merge. Over millions of years, this process resulted in the formation of planets. Since the planets form from material within the disk, they continued to orbit within it. The relatively low inclination of planetary orbits to each other, meaning the angles at which their orbits deviate from a common plane are small, is a direct consequence of their shared origin within this flat, rotating disk. 4. Why the plane remains stable. Over billions of years, gravitational forces from planets and other celestial bodies have shaped the solar system, while interactions between planets, asteroids, and other objects can perturb orbits slightly. The overall structure of the solar system has remained relatively stable. The planet's orbits continue to be aligned with the Sun's equatorial plane due to the strong gravitational influence of the Sun. Additionally, there is no significant out-of-plane force to alter their orbits drastically. The solar system is an isolated system with no external gravitational influences large enough to pull planets out of their nearly coplanar orbits.